Hello class, in this video I wanted to review the Taylor series at zero. So for the Taylor series, if all derivatives of a function f exist at zero, the Taylor series for f at zero is defined to be f of zero plus the first derivative of f at zero times x plus the second derivative of f at zero divided by 2 factorial times x squared plus the third derivative of f at 0 divided by 3 factorial times x cubed, and so on. This has a special name to it called a Maclaurin series, and its interval of convergence is from -1 to 1. So, as an example, I have this. I want to find the Taylor series for f of x is equal to e to the x at 0, right? And we could start taking the derivatives for this, right? So, well, first and foremost, we could put in our function f of x is just e to the x, right? And if we were to evaluate just the function at 0, we get a value of e to the 0 or 1. If I took the first derivative of f of x, that is just, again, e to the x. And if we were to evaluate the first derivative of f at 0, that makes a value of 1. The second derivative is still e to the x, and evaluating that second derivative at 0, still 1. The third derivative of f of x is still e to the x, and again, the value of that third derivative at 0 is 1. If we did the fourth, you could probably guess what that makes. E to the x, the value of that derivative at 0, still 1. And we could keep going down, but I'm just going to write this in the general format of the nth derivative of f of x. That still just make e to the x, and the value of the nth derivative of f at 0 is still just the value of 1. So to write out this Taylor series in its complete format for this is 1 plus x plus 1 over 2 factorial times x squared plus 1 over 3 factorial times x cubed plus 1 over 4 factorial times x to the fourth. And this keeps on going until we get to, let me make that not look like a subtraction symbol on my end. This keeps on going until we get to 1 over n factorial times x to the nth, and it keeps going after that. The interval of convergence for this is going to be -infinity to infinity, as it does indeed depend on what these values of x are, but it'll be between -infinity to infinity. Right, so this is one of our basic Taylor polynomials that we could get for f of x is equal to e to the x. And I have a few of those summed up on here, right? We just did that top one, e to the x, like we saw before. If we did the natural log of 1 plus x, the Taylor series for this expanded out is x minus x squared over 2 plus x cubed over 3 minus x to the fourth over 4. And this keeps going down. The nth general value for this is -1 to the nth power times x to the n plus 1 divided by n plus 1. This interval of convergence is from -1 to 1, including that positive 1 there at the end. And for 1 over x minus 1, we can write out that Taylor series to be 1 plus x squared plus x cubed, all the way down to x to the nth power, adding all those up for that Taylor series. And the interval of convergence from this is from -1 to 1. So let me know if any of you have any questions or concerns. Thank you.